Hello, everyone. Good morning, good afternoon, good evening from wherever you're joining us. My name is Dalia and I work as a community manager here at Kong. I'm super happy to welcome you to our community webinar this month. We have Jacob here today. I will let him introduce himself and we're going to talk about Kong Mesh. Very interesting topic. I'm very excited to share all of this information with you today. Please put all of your questions in the Q&A function on the bottom. So if you see on the bottom, there is chat and Q&A. Please use the Q&A so we can keep track of the questions. And Jacob will take them all the way at the end. So yeah, go ahead, Jacob. Please take it from here.
Okay. Hi. So my name is Jacob. I'm a software engineer working for the Mesh team. And today's topic is multi-cluster failover and observability with Kong Mesh. So this presentation was supposed to be held by Charlie, but he unfortunately couldn't make it. However, he recorded a demo for us, which I will play. But first, let's see on the agenda. So first we will I want to remind you what is Kong Mesh, how does it work, what is the architecture, how we can implement a multi-cluster and multi-zone connectivity with Kong Mesh. Then I will play a demo, and then we can finish with Q&A if you have any questions for me. So let's start. Kong Mesh one-on-one. So with the usual microservices environment, you have different connectivity types in your organization, right? So you have multiple microservices, and then you want to expose this to the external users, right? So for the edge connectivity, you use edge API gateways. Then let's say your organization is fairly big. Let's say it's an airline company, right? And then you have an application to process bookings for the airline tickets. And for example, you have search capability. Those might be like separate applications that are contained from like multiple microservices, and you need to have a connectivity between them. If you are familiar with the DDD, this is basically a bounded context, right? So you can implement this with internal API gateways. So every bounded context would expose their own like API gateway with the API. And the last connectivity type is in-app connectivity. So that's basically your regular service-to-service communication, which is implemented by service mesh. So today we will be focused on the edge connectivity and more important on the service mesh. So why do you even need a service mesh? There are actually like three main reasons why you need a service mesh. First is traffic management. So for example, you want to provide multi-cluster connectivity, right? You have like 3 Kubernetes clusters, you have service in one cluster, you have a service in another cluster. You want to provide a connectivity between both of those clusters. How do you do this, right? So service mesh can help with this. The other one is, for example, blue-green deployment. You may want to shift the traffic, repeat the traffic to some other service, basically traffic mirroring, right? So that's the traffic management. Another big one is zero trust security, right? So by default, network is insecure. So we want to secure this via MPLS. So service mesh helps with this in a way that with service mesh, we intercept every traffic between your services. Therefore, we can encrypt this traffic, and then we can apply different policies. So we can say that, okay, only this service can communicate with that service and not any other, right? And this way we can achieve zero trust security. And the third big one is observability. So Mesh can give you a very detailed stats of a traffic in your organization, right? Including metrics, traces, logging, and so on. So you may ask, okay, that sounds great, but I can do this via my favorite framework or a library, right? Why Service Mesh is better here? And Service Mesh is better because in a big organization, first of all, you may have services that are implemented in different languages, right? If you implement all of those things in the form of a framework or a library, you don't have this consistency for every framework you have in your organization or every language, right? Another thing is it's actually hard to manage this library. So let's say you want to introduce new functionality to manage your traffic, right? Then you need to update this library in every single application that you have in your organization. So in this way, Service Mesh it's actually better because it's implemented on a network level. You don't need to like interact with service owners and so on. You as a mesh operator, as an infrastructure engineer, can provide this functionality without like those big migrations that you have in your organizations. So why Kong Mesh, right? Because there are, of course, different service meshes. So the first reason is that multi-mesh functionality. So in Kong Mesh, you can create multiple virtual service meshes. So going back to this example of bounded context, right? You might have a part of organization for which you want to like isolate your service mesh, and the other part of organization for which you want to have a separate service mesh. So usually you would have to have like two separate deployments. With Kong Mesh, you can just separate those two meshes using mesh resource with one Kong Mesh deployment. Another big reason is universal support. So Kong Mesh is based on Kuma, which is a CNCF project. And from the day one, we wanted to provide a support for not only Kubernetes, but also for virtual machines. So with Mesh, the bigger mesh, the better, right? Because you want to provide this consistency for your whole connectivity in the company, right? And that, of course, includes VMs. Maybe you are in the middle of some kind of migration that you are trying to migrate some VMs to Kubernetes. So you don't have all the workloads on Kubernetes, or you may never migrate some workloads to Kubernetes, but you still want to have them as a part of your mesh, right? So Kong Mesh was designed to support this use case. It also supports very rich attribute-based policies that we will show on the demo. And Kong Mesh was built to support the multi-zone connectivity, right? So again, you may have like different Kubernetes clusters, different clouds, and so on. You want to interconnect this into one mesh deployment. Kong Mesh can support this use case. Kong Mesh is powered by Envoy proxy. So for a data plane component of Mesh, which is responsible for actually passing the traffic between services, we use Envoy because Envoy is a very lightweight proxy. It's very fast. It's written in C++, and it was designed for the service mesh use case. And there are multiple companies worldwide that relies on Kong Mesh to simplify their infrastructure and connectivity story. So let's talk about Kong Mesh high-level architecture, because this will be useful to understand the demo. So those boxes, you can think of them as a Kubernetes clusters. This, of course, can be your network of virtual machines. It can be like AWS ECS and so on. But for the simplicity, let's assume that it's a Kubernetes cluster. So in every Kubernetes clusters, we have a services, and we inject the Envoy proxy next to every service, right, for intercepting traffic. Then we have a zone Kong mesh control plane. So zone control plane is responsible for configuring those proxies, right? So let's say I have a policy called mesh timeout. Zone control plane will be responsible for converting this policy to an XDS config, which is understood by the Envoy proxy. And then we have Kong mesh ingress. So this is zone ingress. Do not confuse this with like your API gateway that you have in the cluster. This is a component purely for passing the traffic for the cross-zone connectivity, right? So let's say you want to, from this service, from the cluster 1, you want to reach other service from cluster 2. You would do this via Kong mesh ingress, right? And then on top of this, we have global Kong mesh control plane. So global control plane is responsible for managing all the policies, right? So it might be a bit cumbersome to manage all the policies between all your Kubernetes clusters. So the way we implement this, you as a service owner, right? You go to global control plane, you apply your policy. This policy is then synced to every cluster. And then a global control plane is also used to see your whole mesh. You see all the services that you have between your zones, all the data plane proxies, and so on. Now, with this architecture in mind, like I said, we are multi-cluster native. We support multi-mesh architecture, so multiple virtual meshes. Our built-in mesh gateway is Gateway API compliant. So with Kong Mesh, you can spin up an Envoy-based API gateway for the north-south traffic, right? So we can use Gateway API for this. We are also involved in Gamma, which is API standard that is developed by the Kubernetes community for configuring and managing various service meshes. We integrate with multiple cloud services, with secret managers like vaults, we support VMs and so on. We embrace OpenTelemetry, which you will see in a second in a demo. And then we integrate with any API gateway. So let's say you have an API gateway already that you want to use, Kong Mesh also integrates with this. Now, Kong Mesh is also a part of a bigger story of our SaaS offering at Kong. So with Connect, we have the end-to-end connectivity story for your API. So first, you start with your API design and you want to test your API, right? So that's the first part. You can use Kong Insomnia for this. Then you want to manage your north-south traffic. So again, that's the edge gateway that I talked about, right? So we offer Kong Gateway and Kong Ingress. And then we have Kong Mesh to manage east-west traffic as well. So we have all the products under one single control plane, which is a Connect control plane. So here we can offer a lot as a managed offering. For example, going back to that Kong Mesh multi-zone architecture, global control plane in this case would be fully managed by Connect, and the zone control plane in your Kubernetes cluster will be connecting to the global control plane in Connect. And before we start the demo, I want to also explain how does policy matching work with Kong Mesh, because it's a big part of the demo, right? So let's say you deployed Kong Mesh. You have all the sidecars, all the traffic is intercepted and so on, and you want to actually implement some functionality on top of this. Here is the example of the mesh timeout policy, which can help you to set a specific timeout on the traffic between your services, right? So to implement this, you apply a custom resource on your Kubernetes cluster called mesh timeout. And then in the spec, you can see the target ref. So the target ref, the top level target ref, is selecting a subset of proxies on which this config will be applied, right? You can select a specific service. You can select the whole mesh, so all data plane proxies. In this case, it would be kind mesh, or you can select the subset of your data plane proxies with mesh subset. So all the proxies with tags team A will have this configuration, right? So now we apply this configuration on those proxies with tags team A, and we say that from, and again, we have a target ref of kind mesh, which means that from any traffic in the mesh, we apply the request timeout of 2 seconds, right? We could say, instead of mesh, we could say mesh service and so on. And some policies can have 2 sections instead of from, or both even, right? So in this case, we can read this that any proxy of a team with team A tags that receives the traffic, the from section, will have the timeout of 2 seconds, right? If we want to configure the outgoing traffic from those proxies, we would have a 2 section. So this is how the policy matching works in Kong Mesh. And this pattern is reused in multiple policies, including mesh load balancing strategy that you will see in a second with a demo. All right, so let's start the demo. Let me share the recording. And yeah, let's start.
Hi, so in this demo, you're going to do something quite standard. You're going to have an application that is composed of a gateway and a set of microservices. And we're going to deploy this same application in 3 different regions, right? So the gateway will have 2 endpoints, a /main endpoint and a /other endpoint. The /main endpoint will lead to a tree of services that call one another, like 0 will call 1 and 2, and 2 will call 3. And then the /other endpoint will call service 4. The one detail is that service 4 will only exist in US West. Right? This is the only region that this service exists in. This happens quite often where you can have replicated services on a region basis, but you have one service that can't be replicated for some specific reasons. Okay, so if we look at a scale up with the different regions up, we can see there's an US region, the US East region, and the US West region, right? Which what happens in our very first demo is that we will disable cross data center routing with the exception of /other. Okay, so now if we get to it, we have a demo that is in this repo that will show it. In this demo, we have these base policies. You can see in these policies, we have a mesh traffic permission because we have TLS to be able to do cross data center routing. And so we allow everything because we want to keep it simple. We have a mesh gateway, right? That has a selector edge gateway that is exposed on port 8080. And we have a mesh HTTP route that is bound to this gateway. This is a new thing in 2.6 that you can bind directly to a gateway. And that says when you reach /main, we actually go to API play 00 as a service. We have another mesh HTTP route that goes from /other to API play 004. Then we have our load balancing strategy. So the default of a load balancing strategy is that it will keep traffic to the local zone and degrade to other zones automatically. But what we want is to actually disable that by default. So it's rather simple with the mesh load balancing strategy. We can set the locality awareness and do a cross-zone failover to type none. So we will not failover to anything. Except that for API play, we actually want to be able to route to it because, as I mentioned previously, API play will only exist in US West. So in that case, we say, for API play, you want to fail over to any, and any, there will only be zone 4, US West, because that's the only place where 4 is. And then we're going to do something is we're going to have a mesh circuit breaker to actually remove endpoints out of the list, mark them as unhealthy if they actually start returning too many errors. In our case, we keep a very simple failure detector that is, if we receive more than 5 consecutive failure, we're going to remove this endpoint for 30 seconds. Okay, so now let's get to it. First, let's demonstrate that if we can close other, if you can call other, you actually get you get out to US West, right? So I'm service 4. I have 2 replicas in US West. Here it is. We can now see here. We can see the gateway that entered is US West, right? And then the traffic actually went to US West. Okay, from Europe West to US West. Okay, we can see that these all matches the same number. So that's it for this endpoint. And then we're going to do main, right? Main is the main call. As a reminder, it will call in the same region the exact same place. Okay, so we run it a few times. You can actually see it goes like the answer is like each service says I'm in Europe West. So we're going to do that like a few more times just to make sure that we have some data. It's going to come up. Okay, here we are. We can see this all happen, and you can see that it's all green, right? So it's always Europe West. So we stay in Europe West. Okay, so now the next thing is we're going to start failing the service. So for this, we're going to do use this little script. Sorry, wrong order of argument. This script is very simple. It's actually just calling a debug container and then sending the curl call to it. And this will actually return one endpoint of API play 00 will systematically return 500, right? So if we try it here now, we do curl main. So this was 200, this is 500, 200, 500, right? It's about 50%. Actually, if we keep doing it, at some point we'll notice that we'll actually stop getting any 500 here, right? We can see there's no more 500 because what happens is the circuit breaker has actually kicked in and we marking this endpoint as unhealthy. Okay, cool. So this is the example of this. We're gonna repair this endpoint. So now it will never return 500 again, right? So here we got it. If we refresh a little bit, we wait for the stats to come in, we'll actually start noticing that there were some 500 that actually came up. Okay, yeah, we can see here there was some 500 returned. Okay, so now how about we do something which is actually leveraging failover. So we're going to just set up failover. For this, we're going to failover at the gateway, right? So we're going to use mesh gateway, edge gateway again. And we'd say whenever we reach any service, what we're going to do is do failover in pairs, right? So US East will fail over to US West will fail over to US East, and Europe West will fail over to US East, right? That way, US West will never talk to EU, and EU will never talk to US West. That might be a choice of latency, for example. Like you can tolerate a little bit extra latency when you fail over, but the cross full US West Europe is not acceptable. So you want to make it a bit smaller. Okay, so what this policy will actually do is this. You can see here that the only place, and are these dotted lines, that we actually fail over is at the gateway. This is actually quite nice, and it's a simple way to do failovers, but it is not the only way. It's just one of the ways to do that. You can do per service. You can actually say that only some services, etc., can fail over. You have the full control thanks to the advanced policy matching that Kuma can provide to you. So we're going to apply this. This is in our policies v0 YAML. So we can see that's just what I showed. So we can do Kuma apply v0 YAML, right? And so now, if we look at the API and we go to our data plane proxies and you do zone Europe West, okay, and we're going to pick our edge gateway. If you look at the policies, you can see we've got a mesh load balancing strategy that is pretty advanced, and we'll pick a bunch of things there. So for everything, for this service, so, and then if we look at the clusters, you will be able to see something is if we pick API play as 0, and we'll filter it out, you can actually see that there are these two endpoints, which are on AT&T, and there's a third endpoint here, which looks like a public IP, and this is in practice the ingress. Okay, so now to do this demo, because this is a little more advanced, we're actually going to rely on something that is called K6. K6 is part of the Grafana suite. It's quite nice because you can easily write like simple load tests and advanced things like that. So we're going to do, for 2 virtual users for 5 minutes, we're going to do this rest, right? And we're going to query the main, and we're going to check if the status is 200, and then we're going to check in the body whether it's coming from US West, US East, or Europe West. Okay, so let's run the test, and then we'll fast forward to the actual results when everything goes well. Okay, so as I said, I've applied my locality aware load balancing, but actually nothing has actually been, there's no failover happening because we'll always return 200. Okay, cool, let's go. Okay, so here we are. Okay, so here we are almost at the end of this test, right? We can see that we've been hovering around 3 requests per second, and that all these requests have been addressed on 723, like all 723 requests have been on Europe West, right? And that we see all of them was status 200. Okay, so this seems quite right? And then now we can have a look at actually what it looks from our telemetry point of view, right? So same thing, we've been hovering around three requests per second, right? For this entire test. That there was no things, no 500s. It's all handled by your request, right? You can see that, we can see that, we can see that. Right, okay. So now what we're gonna do is to actually fail one of these instances. You remember when we were failing, everything was still being addressed by your request. What we're gonna do now is when you fail over, there's gonna be enough unhealthy instances locally to actually start sending traffic to US East. So while the instances are unhealthy, while one of the instance is unhealthy, we will start routing traffic to US East. When this instance gets back into the pool, because 30 seconds has passed, we will stop routing traffic to US East, and you'll see it go back and forth like that as the circuit breaker kicks in and out. Okay, cool. So first thing, we're gonna break, right? We're gonna break API play one of the instances of API play one, not the two of them, right? So 50% of the traffic will actually fail for 5 requests. So we're gonna have 5 failed requests on this one pod, and then we'll start routing traffic to US. That's it. The test is over. We can see that at some point there was peaks of failures and then we restored traffic, right? And this was the case already, right? But what we're interested in is to actually see that the traffic has actually started failing over to the other zone when just after these failures happened, right? So we can see here, there's a few failures, right? And just after that, we can see there's a lot of US East traffic coming in, right? There's a bit of US East traffic. And then it restores and it all goes well. And then the host gets integrated again and we send to US East a bit. And then we restore, etc., right? Like the pattern is very visible here. You can see here we just suddenly just send a bunch of requests to US East. It's pretty simple, and if we look at the stats, it actually shows up pretty well. You can see here that now through the ingress, we've got 174 requests that went there, right? Whereas there's been 221 and 27 errored requests here, whereas here, all requests have actually succeeded. Okay, and as I showed, when everything was going well, nothing was failing over. As long as things go well, things stay in the same data center. This is important for cost savings, but also for latency, right? Because latency can sometimes go up. Okay, so this was our demo. The one thing I'd like to then follow up is this, right? All these dashboards, etc. You can just see all this is in Grafana Cloud. We've built everything in Mesh to be able to use most of the telemetry providers around, right? For your stats, for your traces, and for your logs, right? And this is very simple nowadays. We have this observability policy that has mesh metric, which is brand new in 2.6 that is coming out this week, where we just say, yeah, it's metrics and you want to do it that way, right? And then we have mesh trace, right? For mesh trace, we say we're going to push it to an OpenTelemetry collector that we're going to actually run ourselves. And then we had fun running a collector. This is amazing because your collector has a very simple configuration. So you've got a scrape config for Prometheus. There is actually even OpenTelemetry metrics coming out. But this is still alpha, so I've only used that. And then we just say that you're gonna build a pipeline, right? That sends your metrics, your Prometheus metrics, to Hotel HTTP Grafana. This is very simple to set up, very straightforward, and it works with a lot of different providers. So I've used Grafana Cloud in that case, but you could use Datadog. And there's another demo that you can check out on using different providers with this exact same setup. This is that simple to set up. And this is the kind of great metrics we got out of that, right? We were quite easily able to see that we fell over from Europe West to Europe to US East with these changes, the different 500s and things like that. This is very simple, and one of the biggest advantages of your service mesh is to actually provide you unique visibility on what is happening on your traffic, but not only your local traffic, also your cross-zone traffic, your multi-zone traffic, and being able to build up these things to try it out and understand what happens when failures happen. Well, you can try out and just gain days and see very intuitively what is happening. So I hope I convinced you that the different locality where load balancing features of Kong Mesh are very powerful, and that you can observe all that quite easily with the built-in telemetry. Thanks, bye.
All right. So that was the demo. And now, now we can get to the Q&A. All right, I see there are two questions in the Q&A. So the first one, is there a chart we can see that shows how circuit breaker works? Metrics for outlier detection, for example. Yes. So Kong Mesh ships in with a couple of Grafana dashboards. There is a mesh dashboard, service to service dashboard, and data plane dashboard. You can see this in our docs. And I remember that one of those dashboards actually show metrics for the outlier detection. But if you want to have something, I don't know, more advanced, if we missed something, it's quite easy to build this based on the Android metrics. Okay, I hope that I answered your question. And the next one, do you know if Kong Mesh could be used as an instrumentation component to intercept traffic and generate distributed tracing using OpenTelemetry? So that way we don't need to instrument each service individually. That is a good question. And the answer is that you still need to instrument your application. Because if you think about this, there is no way of correlating incoming request to a service with outgoing request from that service, right? Like you have a bunch of requests that are coming in and a bunch of requests that are coming out, right? You need to have a way to correlate that this is one chain of the requests, right? And because of that reason, you actually need to instrument your application to at least pass the tracing headers. Yeah. All right. That was a good question. Are there any more questions?
Thank you very much, Jacob. That was very, very informative. 2 more minutes. Let's see if you guys have any more questions before we wrap up. No, I think that's it.
All right.
All right.
Thank you very much.
Thank you very much, Jacob. It was a pleasure having you here. Thanks everyone for joining us, and I hope to see you at our next events. That webinar is recorded. You will find it on our YouTube channel. So yeah, have a good evening, good day, and I'll see you soon.
All right.
Bye, everyone.
Bye.